Our next question is, the perpendicular bisectors of sides of triangle ABC meets at I. Prove that IB is equal to IA is equal to IC. So in the information it is given that only one triangle. Let we draw the triangle ABC. So it is ABC. So they said the perpendicular bisectors. So if it is only altitudes, we can draw only perpendiculars, like we can draw only perpendiculars for the sides, and it is perpendicular bisector. So perpendicular bisector means if I draw a perpendicular from A to BC to opposite side, so it will make 90 degrees. That means it is perpendicular to the base on which we drawn that perpendicular, and also it cuts the angle equally. So I am naming it as theta. This one also will be theta. So a bisector, what it will do, it will cut the angle from where we are drawing two equal parts. It will also be the perpendicular for the to which it has drawn, to the side which it has drawn. So like that, for BC also we are drawing one thing which is a perpendicular bisector, which is also a perpendicular bisector. Okay, that's what they specified in the problem. The perpendicular bisectors of sides of triangle ABC meets at I. So the meeting point is I here. So we need to prove that IB is equal to IA is equal to IC. That means IB this one, IC this one, and IA is this one. All three are equal. That's what we need to prove. So first of all, consider any triangle, two triangles, so that they are asking about equality. So equality can be proved according to the congruency very easily. So here I am considering some two triangles so that I can get any relation, any equality relation in the given things. First of all, I am considering some as usual some IBD and IDC. So consider a triangle IBD and triangle IDC. Okay, so in that, here it is 90 degrees, so here also you will get 90 degrees. So the angle IDB will be equal to angle IDC, which is a 90 degrees angle. So IDB, this one 90 degrees, IDC is 90 degrees. So 90 degrees. And one more is there, a common line for those two triangles, which is ID. ID is equal to ID for those two triangles. One more, it is a bisector. So it is a bisector means the thing BD will be equal to DC. Okay, BD equal to DC. So BD equal to DC. So here we have got three equality statements from these two triangles. So these two triangles are congruent. Okay, so when those two are congruent, then their respective sides like IB and IC are equal. IB is equal to IC. So because these two are congruent, so their respective sides, this hypotenuse for this right angle triangles are equal. Now consider another two triangles like this one to get IA also. So consider these two triangles like IA, I will keep F here. So consider these two triangles IAF and triangle IFC. IAF, these two triangles I am considering. Here also there is angle 90 degrees on that side and this side. So angle IFC will be equal to angle IFA, which is 90 degrees, and FC is equal to AF. FC is equal to F since it is an angle bisector. So one more equality, that is IF, which is common for those two triangles. IF is equal to IF. So we have three equalities for those two triangles. So that means those two are congruent. So when those two are congruent, the respective sides or respective hypotenuse are equal. That means IC is equal to IA. So this is equation 1 and this is equation 2. Based on 1 and 2 we can write IC is equal to IB is equal to IA.